In object-oriented programming, encapsulation is a programming mechanism that prevents other objects from accessing data directly. So, for example, this object A is an instance of class A, and this object B is an instance of class B, and we call B the caller class and class A the called class. So in here, object B is trying to access directly the data or the fields of object A. So say for example, this is circle, and this is using circle from our previous example. Say using circle, Java class is the one having the main method, and this is the caller class that calls this Java class circle. In class circle, say we have a data, a field we call radius. Say radius is a field of integer type, and in the main method of class B, we instantiate A so that we could access the radius field of circles. So we would say in here, circle C gets new circle. And then we would say C dot radius, right? Now, this expression is a way of directly accessing the data of object A radius. So this is a direct access. But when we are going to employ encapsulation in class A or in object A, particularly on the class field radius, we do so by using the private access modifier. So instead of declaring radius this way inside class circle, we would say private int radius. So this time, the class field radius is no longer accessible directly because the access modifier of radius is private. Now recall that private is an access modifier in which the field or the method or any object which is defined using the access modifier private, that object or that field will only be accessible inside the class where it is declared. It's not visible, or it is not accessible to other classes outside of the owner class. So again, any object that is defined using this access modifier private, that object is accessible only inside the class where it is declared, or it is only accessible within the owner class. In this case, the private field radius is accessible only within the class circle. It is not visible and not accessible by other classes. So there's no way for other classes like using circle can access directly radius this time. So direct access is not allowed, or it is prohibited. Last time we have this program that computes the area of a circle. So we defined these two Java classes. One Java class circle represents the object circle, having these two fields, radius and area. And the caller class in this case is the Java class using circle. So this Java class using circle called this class circle to be able to access the fields and the methods which are instance fields and instance methods of the called class circle. So in order to do that, we instantiate the called class, creating an instance C, this object or instance C. And after that, we could access all the fields of this class via the instance C. This statement here, or this expression here, is a way of directly accessing the public field radius. So the color class using circle has a direct access to radius because the access modifier of radius is public. Even if we remove public, in this case we are using the no keyword access modifier. So if we're using the no keyword, radius would be visible within the same package only. The color class within the same package as circle are only the ones which could access radius, area, and compute area because we are using the no keyword access modifier for radius, area, and compute area. In this case, radius, area, and compute area are visible only within the package where circle is stored. So if we want using circle to be able to access these fields and methods of this class circle, then these two must be inside the same package because these are only visible to classes within the same package as circle. Let's try to look at the package explorer and check if these two are in the same package. Yes, circle is here and also using circle. Okay, so they are located or stored in the same package, which is the default package in this project. And so the color class using circle is able to access all of these fields and methods which uses the no keyword access modifier. So this is possible, okay, the direct access. As you can see that we are not prompted by error messages. So if we run this again, input the radius of a circle, say 3, and there we have the output. Now, the purpose of these two statements here, although they are the same, is just to illustrate that this color class using circle could also directly access the field area as it can directly access the radius because, again, these two fields use the no keyword access modifier, and since these two Java classes are stored in the same package, then it can access radius and area, as well as the method compute area. This time, let's employ encapsulation by using the private access modifier to declare this field radius. So radius is set to private access modifier, while area is set to no keyword. Area is using the no keyword access modifier, while radius is defined using the private access modifier. And compute area method is defined also by no keyword access modifier. So this time radius will be visible within the same class only. So only the methods of this class circle can access or can see radius. Other classes outside of this class circle, even if it's within the same package, cannot access and cannot see this private field radius. And for area, which is defined or declared using the no keyword access modifier, area is visible only, same as before, within the same package. Now notice in the color class using circle, we get some errors. On this line, the 14th line, the error says the field circle radius is not visible. So why is that? Because we can no longer directly access the field radius because this is now defined using the private access modifier. So the color class using circle can no longer have direct access to radius, even if this is stored in the same package as the cold class circles. So direct access is not possible, which is this one, and this one also. A direct access is not possible, and also this one. But take note, the direct access to area is, it doesn't get an error because area is defined using the no keyword, which makes it visible in the same package. So other classes within the same package, like using circle, has access to this field. That is why this doesn't get us an error, while this one gets us an error, this one and this one. So how do we solve that problem a while ago? The problem that the caller class using circle can no longer access the private field of the cold class. So this illustrates to us what happens when data is not private. Caller classes have direct access to that field which is not private. But if that data or field is now set to private, this is no longer possible. We are now employing encapsulation when we set the access modifier to private. So to solve that problem of not being able to access a private field or a private method, we're going to prepare a method to handle the field and then disclose that method to other objects. So since the caller class using circle, and say this is the main method of the caller class using circle, can no longer have direct access to the data, which is, in our example, it is the private field radius. Okay, direct access is not possible. And so, to solve that problem, we're going to prepare a method, which is this one, which will be the one to handle this data. So this method that we prepare is the one which can directly access the private data. And it is possible, of course, because this method is within the owner class of the data, which is radius. So they are in the same class. And remember that private fields or methods are visible within the class, but not outside the class. And so we create this method, and then this method should not be set to private. This should be disclosed or open or visible to other classes. And so the access modifier of this method, which can directly access and manipulate the private data, should be any of the access modifier except private. If you want this to be visible in the same package only, then you use the no keyword access modifier. If you want this to be visible outside of the package, visible in other packages, then you use the public access modifier. Once this is available, then the caller process will call this method, which will be the one to handle this private data. So it's like this caller process is still able to access the private data, but in an indirect way. So this caller process channels to this method, which has the only access to this private data. If the purpose of this method is to change or set the value of this private data, so the direction is that way, to set or to change, if that is the action of the method, then we call this method a mutator or a setter method of the private field radius. If, however, the purpose of this method is to access this private data so that it gets the value of this data and make that value available to the caller class, meaning this method will return to the caller the value of this private data. Then we call this method an accessor method or a getter method. So in here we will define the accessor or the getter method for radius. Radius is type integer, so this method will return an integer. Say we use the method name getRadius, and it will simply return radius to the caller. And say we define the mutator or the setter method for radius. So since this is mutator or setter, this doesn't return a value to the caller. Say we call this set radius to. So this is set radius, and what it does is it simply set the value of radius to that value of the argument that is passed by the caller. So let's say this is int r, where the value of the argument r is coming from the caller or provided by the caller, and then that value will be the new value of radius. So we change the value of radius to this value coming from the caller. We call this mutator or setter because it will set or change the value of radius, this private field radius, to that value which the caller provides. And this method is called accessor or getter method because it accesses the private field radius and it returns the value of that field to the caller. Then we save this. And in the caller class, if we want to change the value of radius to that value, which is the user input value for radius, then we would call the setter or the mutator set radius, and we call it here. And say, for example, we could declare a local variable int r, where r is this one, r is set to that, and then we pass that value r to the setter or the mutator. So this is c dot, okay, the instance. These two methods are non-static or instance methods, therefore we call them via the instance of circle, which is c. And then for this one, what we want to happen is we want to access the value of radius and display it here. We want to get the value of radius. So instead of this one, we call the get radius method, the getter or the accessor. So we say get radius, and of course this is an instance method, so we access it via the instance C. And also this one is calling the getter or the accessor method. So the getter method will provide or will return the value of radius, while the setter method, the mutator, will change the value of radius to that value which we want to become the new value of radius. So this is now indirect way of setting a new value for radius. And this is an indirect way of retrieving the value of radius, and also this one. Let's save this. Take note that we don't get any error message anymore since we do not directly access the private field radius. We access radius via the setter or mutator method and the getter or the accessor method. Let's try to run this. Input the radius, say 3, and so we're able to successfully run the program. So we run this again, input radius 4, and the radius value is indeed changed to 4, and the area is computed. You may also choose to not use a local variable r. In this case, we remove that and this one, and instead of passing here the value of r, we can pass this in here. Let's try to run this. Let's input 4, and we have here the radius and the area, and another confirmation of the value of radius, which is 4, and the value of area. So you can opt to not use a local variable r. Instead of assigning this user input to a local variable r, and then that local variable r is passed here as argument, we can instead pass this value returned by nextInt, the user input, directly as argument to the setter or the mutator method. In that way, we don't need to declare a local variable r, which temporarily stores the value of the user input radius. In that way, we save RAM space by not declaring anymore another local variable.